quickly share that. Great, this is going to be interesting. I haven't done this for a while. I must say it is really great seeing people in person. I'm quite scared, and thank you for Martin inviting me and breaking me to get on stage. That's been done. I'm going to try and show you a couple of things. I'm not going to go into too much detail, and really just a sliver of what we've been doing the last year or two. It's extended a bit further than that, of course. And I'm just need to make a little caveat here that what I'm going to talk about is very much proof of concept, sometimes deployed on projects. And if the videos are a bit low quality, it's because I've been battling my two kids streaming Dream and Mr. Beast while I'm trying to work on repeater Wi-Fi's. So, but I think the idea is really to get you guys an understanding of where the industry is going and where our kind of technology is going as such. So I'm in our London office. This is around the corner from Covent Garden. We are a global company. I probably work the last 2 years more with the New York office than the London office itself. Some of the work here in London that we are known for, this is the ex-BT headquarters that we've rebuilt. We've kept as much as we can of it and recycled the facades and put new facades in new spaces. This is one of 5 Victoria, which is going to be driving towards a carbon neutral building. And I'm showing this building because this building is very much designed between London and New York. Senior people and junior people on both sides of the Atlantic. And it is really quite difficult sometimes to get to this level of quality if you're not in one room together. So how can we look at the future and how can we make that go forward? Another project here, Bermondsey recently received a MIPIM award. Same kind of concept, collaborative design process with multi-people from all over the world involved. And again, going into details and looking at the detail aspects of those buildings, recycling the buildings and the likes. A little bit about the back end of what we've done sort of the last 20 years regarding technology at KPF. I just want to highlight 2 items there. In kind of 2003, we went to be a global company as such. So we have 9 offices, but we really work across the globe as one network. So we dial an extension, you speak to someone in Hong Kong, for example. And the other aspect is here is around the sort of 2010 area where we started disintegrating or disbanding our speciality groups and put the focus on the designers. So whatever we do, we're trying to get to a designer's table or a designer's desk as such. And this is very much what I'll be talking about as well. I love visualization, so a little bit about some of the visualization we've been doing, and you can see also from a technology point of view, sort of the 2018 onwards when things started ramping up on that aspect. Just a bit more, our technology group globally, we're about 45 people. It spans all these different disciplines: infrastructure, digital practice, which is the BIM computation visualization people, urban interface, environmental performance, data science, and then I sit in applied research. And we really work across the boundaries. There's not siloed entities as such, and this is really a global approach to how we do it. And the focus is from the outside really in towards this sort of digital practice, UI and EP side of things to empower our users. So today I want to talk to you a little bit about some aspects of location independent design and what we can look at towards the future possibly. I said we have 9 offices across the world. We dispersed all over, and it's quite challenging when we have to share files and the likes and be immersive. Now, of course, we have 750 plus independent small offices that we cannot control. And we cannot always control the hardware that these people are working on as well. Which brings to the aspect that we are looking at sort of before pandemic, a very much a global private and public cloud approach. But it was very much in file sharing and data sharing as such. It wasn't really in terms of the compute. And what has happened recently is that we have moved a lot of these functions and we've started building compute servers, geometry compute servers, as well as visualization compute servers. And we are trying to see what we can do that on the cloud side, move the compute away from the cloud where we can't always control what the user is doing and see if we can compute in the cloud and then get the information back to the user. A few years ago, we looked at this approach of machine learning and compute and other functions and how it will affect design. And we're really looking at the designer or the human side being free of understanding where that button is in Revit or Rhino, but really enable them to design, submit a complex computational task that they have to understand, but they don't have to code themselves, it goes and compute on the server and sends them immediate feedback. Right? So a senior designer with incredible amount of knowledge may not know how to operate a Grasshopper script, but can they query a daylight study or anything like that and get the feedback while they're in the zone of trying to solve a master plan? Right? We're trying to get that iterative approach. And of course, when we expand that, we really get to a multi-function that the users have to do. And we have this kind of experience layer that we're looking at where the designers experience the functions that they're doing and the designs that they're doing. And this application layer that is moved from them and sitting sort of on a cloud or a remote platform. And it is quite challenging. So this is how it would look like inside an application, for example. The user don't have to open the script. They have multiple options they can select. They can go run their daylight. And any designer can go and do this. We don't have to have specialists on the team doing that. This is not very new. And what we're looking at is pushing it into multi-platforms. So we're looking at web-based platforms, real-time applications, and mixed reality. And the bottom two is the ones I want to talk to you guys a little bit about. And it is really about these aspects that affect design and how we can get the designers, again, to have this design experience. It really deals with visualization, geometry, and analysis, which I'll show to you a little bit now. We're dealing with spatial data, with social data, and ultimately we want to be able to simulate that back to the designer. For those of you who are in design and actually doing at conceptual stage and early stages, know that it's like writers in a way. When you're in the moment, you have to do as much as you can and get as much as you can out there. And we're looking at how to facilitate that better. So how can we get a 4 file BIM model with Rhino models and about 40 square kilometers of London at 150 mil accuracy in front of a user where we can't control the hardware, right? That is the kind of spot challenge. And can we have that live, running live with them when they do changes? They can actually get the visualization live out of that. And this incidentally is running path traced, so it's not a rasterized rendering or any optimized rendering. There's no time spent in optimizing this model. And I will delve into that a little bit. And one of the applications we are looking at, of course, like a few others, is Omniverse. And this is one of the ways we are doing it. Definitely not the only way, but one of the ways we are doing it, where we can have 2 Revit models open and a Rhino model and feed a central visualization model to the users. This requires some backend setup, of course, and this deals both, and I'll show you later, with the remote compute in terms of geometry, as well as remote compute regarding visualization. It is not a small model. This is probably capping out this 24 gig graphics card, but you can see that the entities are pretty real time. It's running pretty live. The instances on the right are on a different machine to the ones on the left. I've just cropped them together and show you the kind of quality that you can get out. And this is really what we're aiming for. Again, this is a BIM model at DD phase where the user can open this and visualize it in a really high fidelity and high quality. This is one Vanderbilt in New York. These are a sort of construction documentation Revit model. You can see that the actual facade panels are in 3D, they're not mapped. There's no optimization or anything done in this model, and it's very easy for the designers to go and iteratively look at various options and solutions to this. And then more recently what we've done, there's again 3 multi-BIM models. I'll talk about 3 or 4 Revit models put together. No optimization, and this is a direct feedback from the Revit models that we can feed to the user wherever they are in the kind of world. These are animated. I just put parts in there, but this is what you're going to get. And if the user decides to add another floor, they kind of can see it happening in semi-real time. Right? It all depends on the internet availability as such. This is, by the way, these Revit models, by the way, are level 2 full Cobus BIM models. Don't ask me about that. I don't play in that field anymore. So how can we go a little bit further, and how can we start bringing analysis data across to the users? How can we start getting immersion going? A project we recently did was this office design, this office study, and we were really looking at the floor plans. We were looking at how to disperse people coming out of the lifts, to not have them gather and walk the same route as such, how we can have quiet zones and busy zones and interactive zones and fixed static zones as such. So we generate these kind of images for them, running analysis as such. The analysis on many of these that I'll show you now, and I'm showing you two examples, pedestrian agent-based analysis and CFD, because I like them. But the analysis we do run separately. These are not running live at the moment. I'll show you some of the live stuff we are running. But it does give us the quality and the ability to actually give more feedback to these models in semi-real time. So we can go and generate these analyses as such and stream the data directly to the live model for the users, which is what happened here. The assembly of these models as well are multi-model assemblies, so you only affect the part that you actually do want to do. Doesn't have to be a one single model being streamed. And then, as I said, one of the other things we are doing, again, the compute of the CFD may run for anything from 3 hours to 12 hours, depending on what happens. But once we have the compute done, we can stream the post-processing of the compute, the visualization side of the compute directly into the model. And again, we can combine this with various types of models. So in a case like this, one Crown Place here in London, we have the full BIM model and showing the client how we can stream the CFD around the BIM model. Of course, it's not computed on the BIM model, it's computed on a simplified model, but it gives an indication and a more realistic idea of what the wind is doing. What you also have there is a layer underneath, the cut underneath, and that is actually based on predictive CFD, based on a machine learning algorithm, and that runs live from the server side, so not from the client side. I'll show you quickly here a video where you can adjust a single massing or simplified massing. The user don't have to see the grasshopper side. I just had it there because I had to switch functions on and off for the capturing. And on the right-hand side, you'll see that this is actually streamed through a browser. It's actually not running on any application. This is what we're talking about when we talk about streaming. So the user might be adjusting some parameters on the left-hand side, the height of the cut, the location of the massing as such, and on the right-hand side, through a browser, they'll be streaming a path trace image back of that. And again, that path trace image has the full Revit model included, not the block models that they have. And it really allows for a bit of eye candy when you want to go into it, where you can start streaming this without any input. There's no optimization, there's nothing that needs to be done to it. If I go and change the display or the cuts of the CFD, I will see it live running. And it is better to look at it for the designers in a way. Metric data and diagrammatic data is very important for them to read. But of course, for them to be able to see visuals and get into those visuals and actually understanding what the wind will be doing in that specific area, in this case, forcing a downdraft in that they will immediately see that and immediately be able to react to it. And this is, again, semi-real time, semi-running in a real-time environment. In the past, we've done a fair bit of augmented reality as well. This is a visual mock-up of Chapter Living. That's going ahead pretty soon, probably breaking ground pretty soon. These were very important. I feel augmented reality is really where we're going to have a lot of push-through, or mixed reality for that matter, with our clients. We built many of these, and we have had many high-level people, CEOs, have augmented reality headsets on their heads as opposed to VR headsets. They are more comfortable doing that. And in this case, we really wanted to show the apertures and the facade all modeled. But it took a day or two to turn around this model, and it had to be deployed. Whether we deployed remotely or not, it had to be deployed on a piece of hardware. So pretty recently, what we are looking at is running the same without any predefined compute and streaming it at path trace quality to remote devices. So here we have an iPad that runs an augmented reality model of that CFD that I showed earlier, streaming from a remote server. Right, so the remote server will be doing the compute side and streaming it to the iPad. And this is available out there. It's doable. It's just a matter of connecting the dots. And we're really looking at, for lack of a better way, augmenting 2D presentations with the 3D interaction in the front of this presentation, where we can discuss the high visual and understand what's happening in certain parts of the building and certain parts of the project, and then be able to review it in full 3D with natural interaction with that augmented model as such. And then this video, then we can of course start going into, and this is where we're driving it towards a one-to-one approach. So here I am one-to-one looking at the previous model that I showed you and actually walking around it, understanding the agent or the density of the office, I can actually walk around the office as I want to from the tablet or from the headset and get an idea. This is where my kids were really beasting up Mr. Beast on YouTube, so apologies for the capture on that. But there's a lot of promise behind this, and this is what is exciting about what we're doing now. And this is where we can look at this in real time, and we can say, well, can we change the desk layout and see it immediately without any changes? Not something that's pre-compute, not an option that's been designed, not an option that's been done the last week or two by a designer, but really a real-time option, a real-time change to it. And how do we do that in the back end? And this is a little bit of a slide just to show that, and I'll try to point or show you what's kind of happening. We have our file server, which is not new, and we have a compute server sitting out there that has multi-GPUs on it. From there, we run a VM, so the user can actually run a virtual PC, or they can run their own PC for that matter through any of the other platforms. The Grasshopper side of that, in the cases that I showed before, access two things. It accesses run a compute, which is running on a remote server, and it accesses the data center, which is a data server, which is actually sitting in New York as well. So the machine learning compute was running on a remote server as well. And those are all both streamed back into the, in this case, a Rhino file. The geometry from there is then synced with a data server, which is Nucleus in this case, and that is then streamed back to the visualization server. Right? And the visualization server in turn streams that visualization back to the thin client, to the user's whip, through WebRTC or something similar to that, or down to the tablet or the lightweight device that they are looking at doing. So we are really looking at pushing technology away from the users into a cloud-based, whether it's private or public cloud platforms that are out there, so they can actually sit in a cab if they have proper 5G connectivity and so forth, and review models and request analysis and actually view the analysis in full 3D, possibly even capturing it or whatever the case might be is for a rendering. And of course we are pushing, and this is also not 100% new, but we really are pushing in a space where this is simulated, but a space where we can be on site or in location with the buildings in full spec without optimization, not necessarily doing live changes because I don't think that's useful, but also overlaying all the data and all the analysis that actually goes along with the building to understand it, understand what noise levels are, because we can simulate that and show it, understand what wind situations are, what the daylight factors are, and the likes. And this is probably where we will be going in the future for remote immersive design. And that is me. Thank you. Happy to take some questions, by the way, if anybody, if there's time or not.
Yeah, I think we've got time for 5 minutes. Yeah, go ahead.
If there are any questions.
Yeah, down there.
Awesome.
Towards the back. If you repeat the question, Cobus, when you hear it.
Yeah. Can shout. Hey. We were running Omniverse there on some of these, yeah. We were running Omniverse, yeah.
Hello?
No.
Sorry.
No. So the question was there, we were running Omniverse, and if it was custom setup, I think it is.
Was it all Omniverse and did NVIDIA set it up?
No. So it wasn't all Omniverse, and NVIDIA definitely didn't set it up. No, that was all done by me and a couple of other people, so in the office. Yeah, no, definitely not. And some of the work as well, we use in projects. So it's just tricky, and the whole deal about some of the stuff that we do is we try and deploy stuff that's very solid, and when we go to the designers, it is very important. As I said earlier, a lot of the stuff I do is proof of concept and getting the new technology going. We control that in many cases, and then once it gets solidified, we pass it over to our digital practice that actually then does the deployment to the users. So, but there's also, the users don't want to get too involved with tech stuff. They really just want to get down to design. So,
what CFD are you using? Is it multiple different applications? Or
yeah, we use a few. I think this is actually run through OpenFOAM, but we use a couple of other ones. Yeah, there's 2 other ones we use. So.
okay. For the real time?
Yeah, the CFD don't compute real time though. Yeah.
Any other questions?
You can shout.
I'll do it.
Oh, perfect. So Alvise from Aro.
Yes.
I wanted to thank you, amazing work, and awesome of you jumping on to Omniverse so early.
Yeah, it's scary sometimes, but it's all good.
Yes. And I wanted you to comment if you have any comments on collaboration. So how much you think it would be better or even better if you had all different parties on a project or etc. doing this together? Yeah.
I'll just repeat for the people on
Sure.
the live stream. So the question is this just for KPF, or do you have other people working on projects who are also having access to this kind of technology with you?
So not yet, hopefully soon. The big thing about Omniverse is Omniverse is one thing, but of course Omniverse is built upon USD. So and USD is the thing that we are quite excited about. It's a good framework to store our geometry and our data onto it. It's also quite scalable, and it's good for optioneering and changing. So because you can have multi-layer aspects to it. Of course, our use of USD will go beyond Omniverse. But we are probably looking at a project soon where we will use Nucleus as the server. Omniverse is one of the sub-aspects, but there could be other applications like Unreal Engine or the likes, even Max, where we use the USD from Nucleus out. So it's very much about that. That's quite the concept of USD, and it's a new one. It's a difficult one to get into the industry. But the concept of USD is what we really...
What's the mix of GPU on-site versus GPU in the cloud? I mean,
that's a tricky thing. I spoke to somebody from AWS recently. We pay them a lot of money because we use a lot of their compute. So we run a lot of the GPU on their cloud. We are testing some of the new GPU servers for on-prem as well, where we control it, we can scale it. That's one of the big things. So we can run 8 GPUs or as a single or as a split machine. All our users are getting RTX laptops as we speak, and you mentioned availability. That's our battle. But they will be enabled. It's just the memory on the card. And we are building remote machines for if you go across the memory of the actual laptop, you go into a big machine and you request a 1 or 2 GPU.
We know several people on the develop 3D side of things who do product development who have been they've been having clandestine weird meetings with people selling RTX cards in car parks, inflated prices because it's the only way they can get hold of
them. Speak to me afterwards.
It's only 25% more than it actually costs.
Yeah, but the idea is really, I mean, we can't get everybody a $3-4 grand laptop. The idea is to build and continue to build the infrastructure on the cloud for them to be able to access that for the high compute. So
okay. Thanks, Cobus. Thanks, everybody.
Thank you very much.
Right.